A few fun facts about the moon. First of all, like I told you in the other video, the moon does not orbit in the same plane that the Earth orbits the sun. That's why we do not have a solar eclipse every new moon and a lunar eclipse every full moon. The Earth and sun, if they're on this plane, okay, the moon's orbital plane is just tilted slightly. So what has to happen in order to have an eclipse is the nodes in the plane of orbit have to line up. At this little hoop example, if one of these hoops was the plane of orbit for the moon, and let's just say this bigger hoop is the Earth-Sun plane of orbit, and this other hoop is the Earth-Moon plane of orbit, what has to happen is where my fingers are, where the orbital planes cross, those are called nodes. And the nodes have to line up in order to have an eclipse. So if you have a new moon when the moon is here, no eclipse. But if you have a new moon when the moon is at one of the nodes, you would have an eclipse. Same thing with full moon. If you have a full moon here, no eclipse. But if you have a full moon at one of the nodes, you would get an eclipse. You have to remember space is probably multidimensional, but not everything's just on the flat ground like we perceive that on Earth. That's not how it works in space. The Earth, sun has this plane, but the moon has one that's slightly tilted. Truthfully, the moon could have went around us like this. All right, now another fun fact. It takes the moon a little over 27 days to go around the Earth, right, to make an orbit. That's called a sidereal month. But to cycle through a complete set of phases, it takes about 29 and a half days. That's a Sidonic month. Right? So why are there two different numbers? Well, if you think about it, the moon goes around the Earth, but the Earth has to go around Mr. Sun. Imagine going down to the track and taking three people. You put one person in the center at the 50-yard line in the football field, and they would represent Mr. Sun. You put another person walking around the track and spinning 365 times and hoping they don't fall over. That would be the Earth. But then if you add the moon, you would have to have the third person running circles. They'd have to make 13-ish circles around the Earth for one lap, between 12 and 13. Now, the moon is continually playing catch-up. So to get back to the same point relative to Mr. Sun, so we would see the same phase, it takes about 29 and a half days. If the Earth would sit still and just let the moon go around it, it'd take a little over 27 days. One more fun fact. The moon actually does rotate on its axis. It rotates on its axis just like the Earth does, except much, much slower. Okay? So the Earth is here. I've got an X here for the moon. Here's what the moon does. The moon rotates on its axis at exactly the same rate that it revolves or orbits the Earth. So we actually always see the same side of the moon. There's an expression, dark side of the moon. Well, that side of the moon isn't always dark. When it faces the sun, it's obviously light. But we never see it. The only people who have seen with their eyes the dark side of the moon are the Apollo astronauts who have orbited the moon. Okay. So the moon faces us. If the moon didn't face us, or if the moon didn't orbit, we would get to see, or rotate, sorry, we would get to see different sides. But the moon is locked in what is called synchronous orbit, so we're always looking at the same side of the moon. Last fun fact, the moon is responsible for our tides, okay? There is a gravitational attraction between the Earth and the Moon. The Earth is fairly massive, the Moon is fairly massive compared to us, not very massive compared to Mr. Sun, but compared to us, these are massive objects. So there is a force of attraction. Now, that force isn't going to alter the shape of rocks, okay, or the Earth's crust, but water is easy to alter the shape of. So there is like what's called an equatorial bulge due to the moon's gravity, okay? So when the moon's here, we would bulge a little bit. But as the Earth spins throughout the day, that bulge changes places. So if you live in a coastal area, something you pay attention to is high tide and low tide. Well, if you're in a place where it's bulging, that's going to be high tide. And if you're in a place where you're on the other side, it's going to be low tide. Now, tides are strongest in new and full moons because they are directly lined up. They're a little weaker in the quarter phases because the sun affects it just